In a T-12 rapid start ballast, a high voltage capacitor is used to supply additional voltage to the lamp when it starts. This capacitor connects one end of the lamp to the neutral wire. If the fixture lacks grounding, the capacitor forces a current to travel through the fixture's frame and then to ground, potentially through a person. While the current is small, it can create a tingling feeling. Grounding the fixture gives this current a safe path to ground, preventing it from flowing through someone. The humming noise comes from the ballast vibrating. A ballast is essentially a wire coil connected to the lamp. When the lamp is switched on, the current running through the ballast makes it vibrate. Grounding the fixture won't stop the hum, but it can lessen how much the fixture vibrates. Consider the functionality of a rapid start ballast system in fluorescent lighting. Its fundamental purpose involves initiating and regulating the current flow to the fluorescent lamp, ensuring efficient and reliable illumination. Firstly, understanding the rapid start mechanism is crucial. Unlike preheat ballasts that require a warm-up period, rapid start ballasts employ a continuous application of voltage to the lamp electrodes. This high-frequency voltage, typically around 2.5 to 4 kV, creates an electric field within the lamp tube. Secondly, the role of the high-voltage capacitor needs to be analyzed. As mentioned, this capacitor plays a critical role in providing the initial surge of voltage necessary to ionize the gas within the fluorescent tube. Ionization creates a conductive plasma, allowing current to flow between the electrodes and illuminating the lamp. Without this initial voltage boost, the lamp may fail to ignite or exhibit a dim glow. Thirdly, explore the grounding significance in the electrical circuit. Grounding establishes a reference point for voltage, ensuring that all conductive surfaces within the electrical system are at zero potential relative to the earth. This grounding connection serves multiple purposes, including safety and electromagnetic interference mitigation. It protects against electrical shock by providing a low impedance path for fault currents, causing circuit breakers to trip and de-energize the circuit. The grounding system also minimizes the effects of electrical noise and interference on sensitive electronic equipment. Now focus on what happens when a fluorescent fixture is not properly grounded. In this situation, the high voltage capacitor can create a leakage current that flows through the fixture's metal frame. This leakage current can then find its way to ground through unintended paths, such as a person touching the fixture. This can result in an unpleasant tingling sensation or, in more severe cases, an electrical shock. Grounding the fixture provides a dedicated, low-impedance path for this leakage current to flow, preventing it from posing a safety hazard. Furthermore, grounding can also improve the performance and lifespan of the fluorescent lamp. By reducing the level of electrical noise and interference, grounding can prevent premature lamp failure and ensure consistent light output. The grounding connection helps stabilize the voltage within the fixture, reducing the likelihood of voltage spikes that can damage the lamp. The vibrations in the ballast are influenced by multiple factors, including the quality of the ballast construction, the mounting method, and the surrounding environment. A poorly constructed ballast may have loose windings or a flimsy core, which can amplify vibrations. Improper mounting can also contribute to vibrations by allowing the ballast to resonate with the fixture housing. Environmental factors, such as temperature and humidity, can also affect the ballast's vibration characteristics. While grounding may not eliminate ballast entirely, it can sometimes reduce the level of vibration by providing a more stable electrical environment. The grounding connection helps to dampen the vibrations by providing a path for the vibrational energy to dissipate. Discussing the practical implications of grounding fluorescent fixtures. Firstly, it is essential to ensure that all electrical work is performed by a qualified electrician. Improper grounding can be dangerous and may violate electrical codes. Secondly, when replacing a fluorescent ballast, it is important to follow the manufacturer's instructions carefully. Ensure that the fixture is properly grounded before energizing the circuit. Thirdly, regularly inspect the grounding connections to ensure that they are secure and free from corrosion. Loose or corroded connections can compromise the effectiveness of the grounding system. Look at the standards and codes related to grounding electrical systems. The National Electrical Code, or NEC, provides detailed requirements for grounding electrical systems to ensure safety and prevent electrical hazards. Article 250 of the NEC covers grounding and bonding requirements for electrical installations, including fluorescent lighting fixtures. Some key requirements of the NEC related to grounding fluorescent fixtures include 1. All metal enclosures and conductive parts of electrical equipment must be grounded. This includes the metal frame of a fluorescent fixture. 2. The grounding conductor must be sized appropriately based on the size of the circuit conductors. The grounding conductor provides a low impedance path for fault currents to flow back to the source, tripping the circuit breaker and energizing the circuit. 3. The grounding electrode system must be properly installed and maintained. The grounding electrode system typically consists of a ground rod, ground plate, or other approved grounding electrode that is connected to the earth. This grounding electrode provides a reference point for voltage and helps to stabilize the electrical system. Furthermore, there are different types of grounding systems, each with its own advantages and disadvantages. The most common type of grounding system is the equipment grounding system, which is designed to protect against electrical shock hazards. Equipment grounding conductors are connected to the metal enclosures of electrical equipment and provide a path for fault currents to flow back to the source. Another type of grounding system is the system grounding system, which is designed to stabilize the voltage within the electrical system. System grounding conductors are connected to the neutral point of the power source and provide a reference point for voltage. The choice of grounding system depends on the specific application and the requirements of the electrical code. It is important to consult with a qualified electrician to determine the appropriate grounding system for a particular installation. In addition to the NEC, there are other standards and codes that may apply to grounding electrical systems. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards provide guidance on the design, installation, and maintenance of grounding systems to ensure safety and reliability. Improper grounding can have serious consequences. It can increase the risk of electrical shock, damage electrical equipment, and disrupt the operation of sensitive electronic equipment. In some cases, improper grounding can even lead to fires. It is important to take grounding seriously and to ensure that all electrical systems are properly grounded in accordance with the applicable codes and standards. In review, grounding a fluorescent fixture is essential for safety, performance, and longevity. It provides a low impedance path for fault currents, prevents electrical shock hazards, reduces electrical noise and interference, and stabilizes the voltage within the fixture. By following the requirements of the NEC and other applicable standards, you can ensure that your fluorescent lighting systems are properly grounded and safe to operate. Now, consider the physics behind the operation of fluorescent lamps and how the ballast and grounding interact with these physical principles. Firstly, the process of light generation in a fluorescent lamp involves several key steps. An electric current is passed through a gas-filled tube, typically containing argon and a small amount of mercury vapor. This current excites the mercury atoms, causing them to emit ultraviolet, or UV light. The UV light then strikes a phosphor coating on the inside of the tube, which converts the UV light into visible light. The color of the light emitted by the lamp depends on the type of phosphor coating used. Secondly, the ballast plays a crucial role in regulating the current flow through the lamp. Without a ballast, the current would increase uncontrollably, quickly destroying the lamp. The ballast limits the current to a safe level and also provides the necessary voltage to start the lamp. There are different types of ballasts, including magnetic ballasts and electronic ballasts. Magnetic ballasts use a coil of wire to limit the current, while electronic ballasts use electronic components to regulate the current and voltage. Thirdly, the grounding system interacts with the lamp and ballast in several ways. As already discussed, grounding provides a path for fault currents to flow back to the source, protecting against electrical shock hazards. Grounding also helps to reduce electrical noise and interference, which can affect the performance of the lamp. Furthermore, grounding can help to stabilize the voltage within the fixture, preventing voltage spikes that can damage the lamp or ballast. Look at the electromagnetic compatibility, or EMC, considerations in fluorescent lighting systems. EMC refers to the ability of electrical equipment to function properly in its intended electromagnetic environment without causing or experiencing unacceptable interference. Fluorescent lighting systems can generate electromagnetic interference, or EMI, which can affect the performance of other electronic equipment. EMI can be radiated from the lamp, ballast, or wiring. It can also be conducted through the power lines. Grounding plays a critical role in mitigating EMI in fluorescent lighting systems. By providing a low impedance path for EMI currents to flow back to the source, grounding can reduce the level of radiated and conducted EMI. Grounding also helps to shield the lamp and ballast from external sources of EMI. In addition to grounding, other EMC measures can be taken to reduce EMI in fluorescent lighting systems. These include using shielded cables, installing filters, and optimizing the layout of the wiring. It is important to consider EMC requirements when designing and installing fluorescent lighting systems to ensure that they do not interfere with other electronic equipment. Consider also the energy efficiency aspects of fluorescent lighting. Fluorescent lamps are significantly more energy efficient than incandescent lamps. They use about 75% less energy and last up to 10 times longer. Replacing incandescent lamps with fluorescent lamps can save a significant amount of money on energy bills. The energy efficiency of fluorescent lamps is affected by several factors, including the type of ballast used, the temperature of the lamp, and the operating voltage. Electronic ballasts are generally more energy efficient than magnetic ballasts. They consume less power and provide more stable light output. The temperature of the lamp also affects its energy efficiency. Fluorescent lamps are most efficient at temperatures around 25 degrees Celsius. Operating the lamp at higher or lower temperatures can reduce its light output and increase its energy consumption. The operating voltage also affects the energy efficiency of the lamp. Fluorescent lamps are designed to operate at a specific voltage. Operating the lamp at a higher or lower voltage can reduce its light output and shorten its lifespan. There are several ways to improve the energy efficiency of fluorescent lighting systems. These include using electronic ballasts, optimizing the lamp temperature, and operating the lamp at the correct voltage. It is also important to clean the lamps and fixtures regularly to maintain optimal light output. The disposal of fluorescent lamps presents environmental concerns. Fluorescent lamps contain mercury, which is a toxic substance. Improper disposal of fluorescent lamps can release mercury into the environment, contaminating soil and water. It is important to dispose of fluorescent lamps properly to prevent environmental contamination. Many municipalities and retailers offer recycling programs for fluorescent lamps. These programs collect used lamps and recycle the mercury and other materials. You should always dispose of fluorescent lamps in accordance with local regulations. In summary, grounding plays a multifaceted role in fluorescent lighting systems affecting safety, performance, ENC, and energy efficiency. Proper grounding is essential for ensuring that these systems operate safely and reliably and that they do not pose a hazard to people or the environment. By understanding the principles of grounding and following the applicable codes and standards, you can ensure that your fluorescent lighting systems are properly grounded and safe to operate.